Now for this part we've got to find the turning points on the curve y equals x all over 9 plus x squared. And to find turning points, that's where the gradient on the curve is 0. That is when we differentiate this, dy dx, it's when that equals 0. Dy dx, remember, gives the gradient at any point on the curve. So we need to find dy by dx. So how do we go about finding dy by dx for something like this? Well, we've got two functions of x, top and bottom of the fraction. So we need to use something called the quotient rule. And if you've forgotten the quotient rule, just need a reminder, I'll just quickly run through it for you. Only just take a short moment. Okay. You can also find examples on my website about this, but basically if you've got y equals u over v, where u and v are two functions of x, u in this case is the x and v is the 9 plus x squared, it can be shown that dy by dx is equal to the bottom of the fraction, that would be v, times the differential of the top of the fraction, du dx, and then you subtract, and you do this the other way round. You do the top of the fraction, u, times the differential at the bottom of the fraction, that would be dv by dx, and all of this is divided by the bottom of the fraction squared, v squared. Okay, so that's the quotient rule, and we need to be able to use that here. So, looking then at what we've got to do, we've got to take the bottom of the fraction and times it by the differential of the top of the fraction. So we take the bottom of the fraction and always put your parts in brackets. So we got 9 plus x squared, the bottom of the fraction, put it in brackets, and we times it by the differential of the top. Differential of x with respect to x is 1, and I'd encourage you to put that in, even though timesing anything by 1 is just going to leave it exactly the same. Now we go on to this stage, which is minus, and we do the top of the fraction times the differential of the bottom of the fraction. So we've got the top, which is x, and I'd put that also in brackets, times the differential of the bottom of the fraction, and if you times that you'll get 2x. Okay, now it's all divided by the bottom of the fraction squared. So we've got 9 plus x squared all squared. Let's just put that in and put that in brackets, and we square it. Okay, all that we need to do now is just tidy up the top. So we've got 1 times everything in here, so that's just going to be 9 plus x squared. And then we've got minus x times 2x, which is minus 2x squared. And that is all over that denominator of 9 plus x squared all squared. Tidy up the top. 9 is what we've got there. And we've got x squared minus 2x squared, which is minus x squared. And that's all over our 9 plus x squared all squared. Never expand the bottom, by the way. You've just got one term there. Leave it at always when you're using the quotient rule. Just leave it unexpanded. Okay, now at stationary points, well, at turning points, okay, that's what the question was about. Mind you, it would be the same for stationary points. That is, dy by dx, the gradient, would be equal to 0. So I'd encourage you to write that in as well. And so what's that going to mean? Well, it's going to mean that 9 minus x squared all divided by 9 plus x squared all squared is going to equal 0. So if we just carry on down here, if we were to multiply both sides of our fraction by the denominator here, 9 plus x squared all squared, it's just going to leave us with, therefore, 9 minus x squared equals 0. And to solve this, I would add x squared to both sides, so we get x squared equals 9, and then just take the square root of both sides. Don't forget though, the square root of 9 is plus or minus 3. Very easy to forget that minus. Now it did ask for the coordinates of the turning point. So we've got the x coordinates, 3 and minus 3. So what we need to do is find out what the corresponding y coordinates are when x equals 3 and when it equals minus 3. So when x equals 3, what do we have for y? Well, we're going to have 3 over 9 plus 3 squared. Well, 3 squared here is 9. 9 and 9 is 18, so we have 3 over 18. 3 over 18, but that cancels down to 1/6. Don't forget we've got to do exactly the same for when x equals minus 3. And what have we got then when x is minus 3? Well, we've got minus 3 on the top, and we've got simply 9 here. 9 plus 9 is 18, so we get minus 3/18, or basically minus 1/6. So what are our turning points? Well, our turning points are going to be 3, 1/6, and minus 3, minus 1/6. So I haven't got much room to do this, but we'll just come down here, and we ought to say that therefore the turning points, okay, are essentially at 3, 1/6, and at minus 3, and then minus 1/6. So a bit squeezed in there, but that gives us our answer. Okay.